never put the red clothes in with the white ones because the dye in the red clothes will turn the white clothes pink.
In this lab, we wanted to see if the red fabrics would bleed more with the white fabrics throughout different trials.
This is worth studying because if you know what fabrics run the least, you could still wash them with white ones and shorten the amount of loads of laundry you need to do, as well as avoid running a load of light-colored laundry.
Reactive red B 3BF is what dye is used in most fabrics, and it is suitable for cotton, rayon, silk, and blends of rayon and linen. The dye is made up from many elements, a few being chloride, nitrogen, hydrogen, oxygen, sodium sulfide, and a little copper. They come together to create a red color.
The independent variable would be the fabric because we cannot alter that.
The dependent variable would be the qualitative observation of how much the fabrics bled.
The temperature and amount of fabric measured in surface area are things that are going to need to be kept the same so that it does not vary the results. We think that cotton will run the least and be able to be washed with the whites because the fabric is more compact than the others, so the dye should be able to stay within the threads of the fabric.
This would happen because reactive dyes are supposed to bond with protein molecules in natural fibers to provide uniform, vibrant colors that do not bleed. For this experiment, you will need
cotton, linen polyblend, polyester, shears polyester, Tefecta 10% acetate, satin, and rayon.
7 medium white shirts, 1 washing machine, dryer, and package of dryer sheets. Take 1 white shirt and 1 piece of red fabric you will be using, set them side by side, and take pictures of them.
Then put the 2 pieces in the washer together.
Next, make sure the temperature is set to warm, and the time is set to 30 minutes.
Press start and let the load run. Once the load is done in the washer, take the 2 pieces of fabric and put them in the dryer for 30 minutes.
Once the dryer is finished,
Holy cannoli!
Take the 2 pieces out and document them.
We repeated steps 4 through 8 for the rest of the loads of laundry, each containing 1 piece of white clothing and the red fabric. The chart on the screen shows how much red dye bled from each material.
The intensity of the color will be rated on a scale of 1 to 10, 1 being the lowest amount of dye transferred and 10 being the highest.
The results for each trial were judged by 5 people in order to ensure accurate results.
Cotton was a 0 because it did not bleed at all. Linen polyblend was a 9 because it was almost like a store-bought t-shirt. 100% polyester was a 2.5 because it bled a little and you could tell, but it wasn't white anymore.
Shears polyester was a 1 because it did not bleed, but it was not white anymore. Tefecta 10% acetate was a 4.5 because it did become a lighter pink. Satin was a 1 because it did not bleed, but it was not white anymore. And rayon was a 3.5 because it was not as dark as acetate, but it still bled just a little.
These are the before and after pictures of the 7 different loads of laundry.
While doing the experiment, we learned that in order for the colors to bleed, they need to soak in water for a set amount of time.
We learned that cotton did not bleed at all. Most other fabrics bled a little bit, and that blends such as linen polyester were the worst.
The white shirt that was put in with the linen polyblend turned completely pink. So it turns out our hypothesis was correct.
The cotton was the thickest of all the fabrics and bled the least. This shows that thinner fabrics don't hold reactive dye as well as cotton, but aren't going to bleed a ton. Something that impacted the results most was having no set amount of laundry detergent per load. There was no way of knowing what the exact measurement was because of the cup. It just had measurements 1, 2, or 3. Numbers 1 and 2 were very close to each other, so it made it hard to see where you were pouring the detergent.
Even a small amount of laundry detergent could have affected the bleeding opportunity for the fabric. In order to eliminate this error, the next time we would run the experiment, we would use a more accurate measuring device.
The washer has a knob that turns. The knob determines how long the cycle will be and the intensity of the rinse cycle. The knob could have easily been misturned. That would impact our results because it would mean that one load would be able to sit in the water longer than others. This could be prevented by doing multiple trials so that it would average out in the end.
Doing this experiment proved to be a productive idea because we learned what types of red fabric we can put in the laundry with white.
By knowing this, we can cut the amount of time needed to do laundry in half.
We also learned that if the fabrics sit in water, they will bleed, but if they are constantly spinning, then it is much less likely for a white to end up pink afterwards.
There are certain sheets that you can buy to put in your loads of laundry that will prevent colors from bleeding, but that costs money.
By getting the result we did, we know that certain fabrics won't bleed and we won't ever have to spend money on color catchers.